Let's work on part B of this question. And what can we see here? Again, we have this improper integral, we have this limit thing, but we also have an expression that we must substitute to solve. So we're going to do both things in one question, substitution and this improper integral. So first of all, let's just rewrite this with that limit concept. So we will have the limit when a approaches negative infinity, and we're going to substitute a into this lower boundary. So we're going to have the integral from a to 0, the integral from a to 0 of 2x divided by e to the power of x squared times dx. Now, what do we do from here? We said that we're going to use substitution, so let's see what we can substitute. Well, we can substitute x squared with a u, because the derivative of that is going to be 2x. So we can see the relationship, the connection that we're looking for. So if we do u equals 2x squared, what's going to be the derivative? Well, we will have du divided by dx. So we have over here du divided by dx equals to the derivative of x squared, which is 2x. Now if we do a cross product, a cross multiplication, we will have that du is equal to 2x times dx. Now 2x times dx is equal to du, meaning we could substitute that over here, and let's see what we'll have. That's going to be the du. On the lower side we have e to the power of u, and what we also need to know is that we will have to change the boundaries, because we changed the expression from the variable of x to the variable of u. So let's see how the new boundaries are going to look like. When x, let's put it like that, x equals to 0, what is u? U would be 0 to the power of 2, 0 to the power of 2, so that's 0. And when x was equal to a, u must equal to a to the power of 2, so that's a squared. Now with this in mind, we could write this entire expression in a different way. So let's see how we're going to do that. From here we'll have the limit when a approaches negative infinity, and we'll have the definite integral from what was it, a squared to 0. So a squared to 0, and we're left over here with du divided by e to the power of u, right? We're left with du divided by e to the power of u. Okay, what's that? Let's just rewrite it in a different way to see how we can solve it. Let me just zoom out to get some more space over here. So like that, and we move on. We will have the following. We'll have the limit when a approaches negative infinity, and we have the integral between a squared to 0. Now du divided by e to the power of u, that's just e to the power of minus u times du, and we saw a couple of videos ago what is the property of this integration. The result would be just minus e to the power of minus u. So if it's minus e to the power of minus u, and we have the boundaries from a squared to 0, so we have to keep that in mind as well. We have the boundaries from a squared to 0. Now with this said, just a second, by the way, e to the power of minus u, yes, that one. So with that said, we could substitute the values. So we will have substitution of 0 into here, and then the substitution of a squared. And one more thing I just missed right now, we also have to keep the limit in mind. So the limit is also going to be here as well. The limit of a approaching to negative infinity. We'll substitute it in the end. Okay, so let's solve it over here below. The limit of a approaching negative infinity. What do we have now? We have minus e to the power of minus 0. So that's just e to the power of 0. Then we subtract, and what do we have in the other substitution? Well, a squared is gonna go into u. So we will have minus, and this entire term substituted. So it's in brackets minus e to the power of minus a squared. Hope this makes sense. Again, just keep track of the signs. Make sure you don't miss the signs, because that's gonna mess everything up. What do we have as a result? We have the limit of a approaching negative infinity. Now in brackets we're left with minus e to the power of 0, so minus 1. Minus converts into a positive, so plus e to the power of minus a squared. E to the power of minus a squared, that's the same as 1 divided by e to the power of a squared, right? We just put the power down. With that said, let's start substituting the infinity to see what we get. We would have minus 1 plus 1 divided by e of a to the power of 2, and now we're going to substitute the negative infinity into a, right? That's what a is approaching. A is approaching negative infinity, and we take that to the power of 2. Now negative infinity to the power of 2 is going to become a very large number squared, which becomes positive and even larger. So what we're going to have from that, is minus 1 plus 1 divided by e to the power of infinity, and e to the power of infinity is also going to approach infinity because e is a number, and number to the power of a very large number, it's even larger than that. So it's minus 1 plus 1 divided by infinity. Now we know from the limit properties that whenever we divide 1 by a very large number, that number is going to approach 0. Minus 1 plus 0 is just going to be minus 1, meaning that the area under that function is actually going to converge to a value. That area is going to be equal to minus 1. So yes, that limit is convergent. Hope this makes sense, and we are done.